Unit 3, Vector Calculus. In this unit, we will say vector differentiation and vector integration. In vector differentiation, we will see gradient, divergence and curl, directional derivative, irrotational and solenoidal vector fields, and vector integration we will say simple problems on line, surface and volume integrals, and then Green's theorem, Gauss divergence theorem, Stokes theorem problems without proof. Now first we will say what is gradient, divergence, etc. So first of all, this del is nothing but the reciprocal of triangle symbol. In 3 dimensional, this del expansion is I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. This is the expansion for our del. Now your gradient pi is nothing but del pi. Your del pi is equal to del expansion is I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z into this pi. Pi is a scalar quantity. Now multiply this pi to the entire bracket terms. You get I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. This is the expansion of del pi. This del pi is called gradient pi. And then the next directional derivative, and simply it is called dd. This directional derivative is nothing but your gradient pi, that means del pi dot a vector by modulus a vector. Del pi dot a vector by modulus a vector. In vector, we have 2 types of product. One is dot product and another one is cross product. That cross product I will tell you later. Now here it's dot product. And the next one, a unit normal vector to the surface pi, which is a function of xyz, is equal to some constant, say is this gradient of this value, that means del pi, by its magnitude. Magnitude is nothing but modulus of this del pi. This modulus of del pi is called magnitude of del pi. So this del pi by modulus del pi is called unit normal vector. And the next one, if suppose 2 surfaces are there, namely pi 1 equal to c1 and pi 2 equal to c2. Both pi 1 and pi 2 are scalar quantity, which is a functions of xyz. Then the angle between these 2 surfaces pi 1 pi 2 is nothing but cos theta is equal to del phi y by modulus del phi 1 dot del pi 2 by modulus del pi 2, which is nothing but del pi 1 by modulus del pi 1 means first unit normal vector dot del pi 2 by modulus del pi 2 means second unit normal vector. It is also called cos theta is equal to n1 cap dot n2 cap, where n1 cap is the unit normal vector of first surface, n2 cap is the unit normal vector for the second surface. Next one, if 2 surfaces are orthogonal, orthogonal means perpendicular, then perpendicular means put theta equal to pi by 2, so cos pi by 2, cos 90, which is 0. So cross multiply this, so 0 is equal to del pi 1 dot del pi 2, that's here. 2 surfaces are pi 1 equal to c1 and phi 2 equal to c2 orthogonal if the condition is that dot product will be 0. So based on this vector differentiation formulas, we will see the problems. Now the problem 1, if del pi is equal to 2xyz cube I vector plus x square z cube j vector plus 3x square y z square k vector. Then find pi, which is a function of x, y, z, and given that phi of 1 comma minus 2 comma 2 equal to some initial conditions given. This initial condition is useful to find the constant. Okay, our aim is to find pi. That means the scalar quantity I will find based on this del pi. Okay, first of all, del phi. Already I given del phi formula. What is del phi? I vector dou pi by dou x plus j vector dou pi by dou y plus k vector dou pi by dou z. That's instead of del pi, I will write this, which is equal to, in right hand side I given the value. Now compare these two, because the left hand sides are del pi. Then comparing the right hand sides. So comparing equations 1 and 2, that means these two equations. Here I vector component is dou pi by dou x. In second equation, I vector component is 2xy z cube. That's I written here, which is called equation number 3. Similarly, j vector component is dou phi by dou y, which is equal to, in second equation, j vector component is x square z cube, and in first equation, k vector component is dou phi by dou z, which is equal to, in second equation, k vector component is 3x square y z square. So from the equations 1 and 2, I got dou phi by dou x, dou phi by dou y, and dou phi by dou z. From this, my aim is to find pi value. Here dou pi by dou x, it means this pi differentiated with respect to x partially, that means dou. From this, I need phi value. Here differentiated with respect to x, I need phi value from this. It means, what's the reverse of differentiation? Which is integration. That means integrate this equation with respect to x. Similarly, in second, that means the fourth equation is dou phi by dou y. That is, this phi differentiated partially with respect to y. From this I need pi. That means integrate with respect to y. Again, integrate with respect to z, this last fifth equation, then you get phi value. And write it all the mutual terms in this 3, 4, 5, we get it required scalar quantity pi. But I will do it. So from equation 3, dou phi by dou x equal to 2xy z cube. Now I integrate this with respect to x. So 2 is constant. When I am integrating with respect to x, this y z cube, other variables are also constant. So I am integrating only x term. All these are in product. So 2y z cube is constant. X integration is x square by 2. X integration is x square by 2. Both 2 and 2 gets cancelled. We get x square y z cube. Say x square y z cube. I am integrating with respect to x. Generally, after integrating, we are adding constant like c. Here I am integrating with respect to x. That's why the constant will be in terms of y and z. Keeping the constants are y and z. That is the constants I am writing here, f1 of y comma z. It's not compelled to write f1. You want g1 of y comma z or h1 of y comma z. Something in terms of y and z. Okay. Similarly, I am integrating equation 4. That means this equation with respect to y. See here, there is no y term. That means this x square z cube is entire thing is constant. So we have only integral dy. What is integral dy? Y. So we get x square z cube y. That is x square y z cube. That is for pi. Here I integrated with respect to y. Then the constant is in terms of x and z. That's I written here x square y z cube plus the constant I write f2 of, already I used f1. So some different notations I can use here, like f2 of y and z. And the next one, integrating with respect to z, the last one. So 3x square y z square. This is dou phi by dou z. I am integrating with respect to z. Then 3x square y, entire thing is constant. Z square, its integration is z cube by 3. And 3 gets cancelled. We get x square y z cube, the same thing. So x square y z cube. Now the above three equations, I am writing only the mutual terms, that means independent terms. So phi is equal to the independent terms, like different terms only I can write. X square y z cube I return. The second, which is same as first, so no need to write. The third one, which is same as first, said don't write. So we write only the mutual terms. So x square y z cube and this f1, f2, f3, all these things I written clubbed as C. So finally, this phi is equal to x square y z cube plus C, where the C is a constant. My aim is to find this C with the help of this initial condition. It is given in the problem. Say phi of 1 comma minus 2 comma 2, which is equal to 4. It's given. So with the help of this initial condition, I can find C value. So put x equal to 1, y equal to minus 2, z equal to 2. So substitute this, I will substitute x equal to 1. So 1 square is 1, y is minus 2. 1 into minus 2, which is minus 2, and z is 2. So 2 cube. 2 cube is 8. 8 into minus 2, which is minus 16. Plus C equal to this 5. 5 value given in the problem as 4. So this minus 16 goes to the right hand side as plus 16. Already I have 4. So 4 plus 16, which is 20. So finally substitute the C value as 20 here. Then the required pi is equal to x square y z cube plus 20. That is your required scalar quantity pi. Okay, we go to the next problem. Prove that curl f vector equal to gradient divergence f vector minus del square f vector. So before that, you know gradient. Gradient is nothing but del phi. Divergence is nothing but dot product. That means del dot f vector. Curl f vector. Curl is nothing but del cross f vector. That's initially I told that we have two types of vector product. One is scalar quantity, that means del dot f vector, and then vector quantity, that is del cross f vector. So first of all, we don't know f vector. So I will take randomly f vector as I component, j component and k component. That is f1 I vector plus f2 j vector plus f3 k vector. Now curl f vector. Curl f vector means del cross f vector. That is called curl f vector. So cross product in the sense determinant. In del and f vector both are having ijk as common. So the first row is ijk and the second row in the determinant is first one curl, that means del cross. In del your I component is dou by dou x, j component is dou by dou y, k component is dou by dou z. That's initially I said del is I dou by dou x, j dou by dou y, k dou by dou z. So I component in del is dou by dou x, j component in del is dou by dou y, k vector component is dou by dou z. That's I written here. And the third row is nothing but your f vector. In f vector, I component is f1, j component is f2, k component is f3. So expand this determinant, which is equal to, I think already you know how to expand this determinant, I vector into, omit the column and row. Then we have 2 by 2 matrix, expand this determinant, So first dou by dou y of f3 minus dou by dou z of f2 minus j vector into omit the column and row. We get dou by f3 by dou x minus dou f1 by dou z. From that I will take minus, so it's I directly put it as plus. So dou f1 by dou z minus dou f3 by dou x into j vector plus k vector into omit the column and row. Then we have 2 by 2 matrix. So expand this determinant, dou by dou x of f2. See here, dou f2 by dou x minus dou by dou y of f1. That means dou f1 by dou y. This is your curl f vector. Now see the left hand side is curl f vector. So we got curl f vector. So once again we will find curl f vector. So curl is nothing but del cross. Once again del cross product comes. So determinant I vector, j vector, k vector is your first row, and in del I vector term is dou by dou x, j vector term is dou by dou y, k vector term is dou by dou z, and then curl f vector. So curl f vector, see the last equation, your I vector component is dou f3 by dou y minus dou f2 by dou z. That's I written here. And then j vector component is dou f1 by dou z minus dou f3 by dou x. See the second one. And the k vector component is dou f2 by dou x minus dou f1 by dou y. So I written here. So once again expand the determinant. I can use summation short form I can use here. Otherwise you can write it elaborately like I vector into this minus j vector into this plus k vector into this. So it will be lengthy equations. So you can rewrite in short form. Put summation. Summation is nothing but like I vector. Summation means plus j vector plus k vector. The similar terms we can write. So that's why I use summation. I write only I term. It's understood for j and k. So I vector into omit the column and row. So we have 2 by 2 matrix. Expand this determinant dou by dou y of this. Say dou by dou y of dou f2 by dou x minus dou f1 by dou y. And then minus dou by dou z of this. Dou by dou z of this. Which is dou by dou z of dou f1 by dou z minus dou f3 by dou x. Now multiply this bracket terms. So dou by dou y with this bracket terms. That means dou square f2 by dou y dou x minus dou square f1 by dou y square minus, again I multiply dou by dou z with this bracket terms. Dou square f1 by dou z square minus into minus plus dou square f3 by dou z dou x into I vector. That's here. Now dou square f2 by dou y dou x, that's I written here. Dou square f3 by dou z dou x also I written here. So write the terms dou square f1 by dou y dou x square and minus of minus plus dou square f1 by dou y square plus dou square f1 by dou z square. Actually in the previous equations we have only 4 terms, but here see that it is 6 terms. So 2 terms are extra. I will tell you why I add and subtract the 2 terms. See, I have dou y dou x, dou z dou x. So the missing combination is dou x dou y is here, dou x dou z is there, dou x is missing. X with y, x is with z is there, x with x is missing. So that's why I add dou square f1 by dou x square here and subtract this dou square f1 by dou x square. When plus or minus gets cancelled, we get the same previous equation. Why I am doing this? See, I need the similar terms. See here y square z square is there. I need x square also. So that's why I add and subtract. Then the equation will not apply. So from this take dou x as common. All these 3 terms I will take dou by dou x as common. When I take dou by dou x, then we get dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z minus, from all these three terms I have f1 is common. See the numerator, all the terms I have f1. So I will take f1 as common. We get dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Now this is summation. So dou by dou x of this dou f1 by dou x, dou f2 by dou y, dou f3 by dou z, which is nothing but del dot f vector. This is called dou f1 by dou x, dou f2 by dou y, dou f3 by dou z. This is the expansion of del dot f minus this dou square by dou x square plus dou square by dou y square plus dou square by dou z square. It is called del square. This f1 into I vector. Now expand this summation. When I expand this summation, we get I vector of this plus j vector of this. When I am using j vector, then put x as y plus, again instead of I will put k, then here change as z. So dou by dou z of del dot f minus del square f1i is the first term. So summation means plus. Similar terms we can write f1i, then the similar terms are f2j plus f3k. That's here. Now which is nothing but already know I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z is nothing but del, and this del dot f is here minus del square this f1i plus f2j plus f3k, which is nothing but f vector. See the equation, your f1i plus f2j plus f3k is nothing but f vector. Hence curl of curl f vector is equal to del of, which is gradient, del dot f vector, that is divergence f vector, minus del square f vector. That is our required aim to prove. This is our required aim to prove. Okay, the next problem, show that del square of r power n equal to n into n plus 1 into r power n minus 2, where r square is nothing but x square plus y square plus z square. Find the value of del square of 1 by r. Del square of 1 by r they are asking additionally. First I prove this. With the help of this I need to prove this. Okay, I cannot find directly del square r power n. So first I will find del r power n, and then I will find del square r power n. So what is del r power n? Del is nothing but I vector dou by dou x of r power n plus j vector dou by dou y of r power n plus k vector dou by dou z of r power n. R power n, what is the differentiation? Like x power n. X power n differentiation is n x power n minus 1. So in this case, r power n differentiation is n r power n minus 1 into that r with respect to x. So r with respect to x means dou r by dou x. That dou r by dou x value is x by r. Dou r by dou x value is x by r plus j vector into, again I am differentiating this r power n with respect to y. So r power n differentiation is same, n r power n minus 1 into dou r by dou y comes. Dou r by dou y is nothing but y by r plus k vector into r power n differentiation is n r power n minus 1 into dou r by dou z. Dou r by dou z is nothing but z by r. So the denominator r power 1 bring into the numerator So this r power 1 comes to the numerator as r power minus 1. Already I have r power n minus 1. So r power n minus 1, r power minus 1. So base is equal, then club the powers. Here the power is n minus 1 and this power is minus 1. So I get n minus 2. So I vector into n r power n minus 2 into x plus j vector into n r power, once again this power 1, bring into the numerator r power minus 1. So already it is r power n minus 1. So r power minus 1 you get n r power n minus 2 y plus k vector into the same way n r power n minus 2 into z. So what is common in all these three? N r power n minus 2 is common. So take n r power n minus 2 as common. We get xi plus yj plus zk. What is xi plus yj plus zk? Which is nothing but your position vector r vector. What is r vector actually? Xi plus yj plus zk. That means r vector. Hence your del r power n is nothing but n r power n minus 2 into r vector. From this I will find del square r power n. So del square r power n is nothing but del of del r power n. Del of del r power n. Say del dot del r power n is nothing but del dot, this del r power n just before we got it as del r power n is nothing but n r power n minus 2 into r vector. So I written here n is constant, you take out del dot r power n minus 2 into r vector. So UV rule we can apply differentiation. What is UV rule differentiation? U into V dash plus V into U dash. So in this way del of r power n minus 2 into r vector plus I am fixing r power n minus 2 and differentiating this r vector, because del is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z. That means differentiations. I will repeat again this step. Del dot r power n minus 2 into r vector. So both r and r vector having x, y, z. So I can apply product rule. So product rule differentiation is I am fixing r vector, differentiating r power n minus 2 plus vice versa. That means I am fixing r power n minus 2, differentiating this r vector. So r power n minus 2, what is the differentiation? N minus 2 r power n minus 3 into that r with respect to x is x by r, like previous step, x by r. Once again this r power 1 comes to the numerator as r power minus 1. So already I have r power n minus 3, because this r power n minus 2 differentiation is n minus 2 r to the power n minus 3. This r power minus 1 also comes, we get r power n minus 4 into xi comes. Similarly yj comes, zk comes. So r vector dot this r vector plus r power n minus 2 del r vector. So del r vector value is 3, because del is nothing but I dou by dou x, j dou by dou y, k dou by dou z. R vector is nothing but xi plus yj plus zk. That means x with respect to x is 1, y with respect to y is 1, z with respect to z is 1. So 1 plus 1 plus 1, which is 3. So instead of del r vector, I will write it as 3. So del r vector as 3. R vector dot r vector. So what is a vector dot a vector? Which is a square. So in the same way, r vector dot r vector is r square. So n minus 2, both r power n minus 4, this one is also r square. Both base is r. Then club their powers. That means add the powers. So here n minus 4. This one plus 2. So what is n minus 4 plus 2? N minus 2. So finally it comes n minus 2 r power n minus 2 plus 3 r power n minus 2. So both the terms are having r power n minus 2. So take r power n minus 2 as common. Then this is n minus 2 plus 3. What is n minus 2 plus 3? N plus 1. Hence, del square of r power n is equal to n into n plus 1 into r power n minus 2. This is our aim is to prove. See the problem? Del square r power n is equal to n into n plus 1 into r to the power n minus 2. Okay, in the problem, additionally they are asking one more term. Find the value of del square 1 by r they are asking. Find the value of del square of 1 by r. See here we proved del square r power n. So at what value of n we get this 1 by r terms comes. See when I put r n equal to 1, then I get del square r only I get. Here 1 by r I need. That means put n equal to minus 1. So this is del square r power minus 1. So put n equal to minus 1 in RHS also. So whatever you are substituting in left hand side, do the same for the right hand side also. So put n equal to minus 1, then this r power minus 1, bring into the denominator, you get 1 by r. And the right hand side minus 1 plus 1. Here also n is minus 1. So minus 1 into minus 1 plus 1. What is minus 1 plus 1? So 0. 0 into anything, it is also 0. So finally, del square 1 by r which is equal to 0. This is they are asking. Okay, next we go to vector integration. In vector integration, already I told that 3 theorems are there, namely Gauss divergence theorem, Stokes theorem, and then Green's theorem. These statements are useful in part A question, because in part A they are asking state Green's theorem, state Stokes theorem, or state Gauss divergence theorem. Only statement they are asking, because in our syllabus without the proof of this theorem. So maybe they will ask in part A. What is Gauss divergence theorem says? So divergence, already you know, divergence is nothing but dot product. Say double interval S f vector dot n cap into ds. Here dot product, which is equal to triple interval V divergence f. What is divergence f actually? Del dot f vector into dv. This formula is called Gauss divergence theorem. Similarly, Stokes theorem is nothing but interval say f vector dot dr is equal to double interval S curl f vector dot n cap into ds. What is curl? Del cross f vector. Divergence means del dot f, curl is del cross f. This is called Stokes theorem. And Green's theorem is nothing but interval say p dx plus q dy, which is equal to double interval r dou q by dou x minus dou p by dou y into dx dy. This is called Green's theorem. So some of the textbooks they are using pq, or some of the textbooks follows mn or uv also, like m dx plus n dy is equal to double interval over r dou n by dou x minus dou m by dou y into dx dy. Both are same. They can use pq or some different notations also. So this is called Green's theorem. Okay, we will say problems based on this Gauss divergence theorem, Stokes theorem, and Green's theorem. So the first problem based on Gauss divergence theorem. Verify Gauss divergence theorem for f vector is equal to x square minus yz into I vector plus y square minus zx into j vector plus z square minus xy into k vector. It's a 3-dimension taken over the rectangular parallelopipe bounded by the planes x equal to 0 to a, y equal to 0 to b and z equal to 0 to c. That means all the three sides are different, like x, y, z, length, breadth, height. It is called parallelopiped. In two dimensional it is called rectangle. We have only length and breadth. The same extend into three dimensional it is called parallelopiped. Length, breadth and then height. Like our college note. Say it has six surfaces are there, bottom, top, and then left, right, and then this two sides are there. So totally we have six surfaces. So they are asking verify Gauss divergence theorem for this. By Gauss divergence theorem, what is your formula for Gauss divergence theorem? Double integral over S f vector dot n cap into ds, which is equal to triple integral over v del dot f vector into dv. So I will find first right hand side and then I will find left hand side and check whether they are equal or not. If it is equal, then we conclude Gauss divergence theorem is verified. Otherwise, you can conclude Gauss divergence theorem is not verified. So first I will find the right hand side part. For the right hand side, I need divergence f. Divergence f means I want del dot f vector I need. So f vector is given in the problem. From that, find del dot f vector. Del dot f vector. What is del expansion? I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. That means I vector into, I am differentiating this with respect to x. X square, what is the differentiation? 2x and minus y z. This is I will differentiate with respect to x partially. Partial in the sense I will differentiate only x term. There is no x term here. That's why it is constant. Hence constant differentiation is 0. Plus j vector dot j vector is 1. So differentiate this with respect to y. Y square differentiation is 2y. And the next one there is no y. Once again its differentiation with respect to y partially is 0. Plus k dot k is 1. Z square differentiation is 2z minus xy. There is no z term here. Hence its differentiation with respect to z partially is 0. So we have 2x plus 2y plus 2z. Take 2 is common from all this. You get x plus y plus z. This is your required del dot f vector 2 into x plus y plus z. Now the Gauss divergence theorem right hand side part is triple integral over v. V stands for volume. Divergence f, that means del dot f into dv. So del dot f value is 2 into x plus y plus z. And then limits we need. The limits are, first of all, dv is dx dy so three-dimensional. Here given in the column, x running from 0 to a, y is 0 to b, and z where is 0 to c. So that's I will put it here. So x equal to, so it's integrate this. 2 is constant. Take out from the entire integration. First I will integrate with respect to x. X integration is x squared by 2 plus y and z are constant. So integral dx is x only. So x into y plus x into z. Between the limit x equal to 0 to a into dy dz. Put x equal to a. So a square by 2 plus ay plus az. This is for upper limit. And lower limit is 0. When I substitute x equal to 0, then 0 square is 0. 0 into anything is also 0. 0 into anything is also 0. So hence all the terms will be 0 for the lower limit. So we have 2 into double integral 0 to c, 0 to b. A square by 2 plus ay plus az into dy dz. See here, y. So integral 0 to c. To y, this a square by 2 is constant. So we have only integral dy. Y is constant. We have y dy. Y dy, what is integration? Y square by 2 plus az is constant. Integral dy, which is y, between the limit y equal to 0 to y equal to b. So a square b by 2 plus a b square by 2 plus a b z into dz. So integrate directly with respect to z. So 2 into a square b by 2 is constant. We have only integral dz. What is integral dz? Z plus a b square by 2 is constant. We have only integral dz. Integral dz is z plus a b z dz. So a b is constant. Z dz integration is z square by 2 between the limit z equal to 0 to c. That's here. Substitute z equal to c. A square bc by 2 plus a b square c by 2 plus a b, I put z equal to c bar. So a b c square by 2. And lower limit when I substitute of z equal to 0, then all the terms will be 0. So what is common now? A, B, C is common in the entire numerator of all these three, and denominator is also 2 is common. So take A, B, C by 2 as common. So 2 gets cancelled. When I am taking A, B, C as common, then I get A plus B plus C. This is for our RHS. So hence Gauss divergence theorem RHS value is A, B, C into A plus B plus C. Now I go to LHS. What is your LHS? Double integral over S, F vector dot n cap for your LHS. So LHS I can find, it's a 6 surfaces already told that, namely S1, S2 bottom top, S3, S4 they are left and right, and SY, SX these two sides. So S1, S2 are parallel, S3, S4 are parallel, SY, S6 are parallel. In first surface x equal to 0. So when x equal to 0, then the unit denominator is minus I. When x equal to some quantity like A or B or something, then n cap equal to plus I. So x axis, so that's why plus I. Similarly, when y equal to 0, then n cap is minus j. When y equal to some quantity it moves, then n cap equal to plus j. And z equal to 0, then n cap equal to minus k. And z equal to some quantity, then n cap equal to plus k. So this is your n cap. That means unit normal vector. Okay. First I will find x equal to 0. Before that, f vector dot n cap. Already f vector is given in the problem. What is given? F vector is x square minus yz into I vector. This is your f vector. So here n cap we assumed as minus I. So minus I when I take I dot I1, so minus sign only I have. Here x is 0, so then this term will be 0. Minus or minus plus, so we have only yz. See? Yz. Into ds. In x direction ds is dy dz. In y direction ds says except y, that means dx dz. Similarly, z direction ds says dx dy. So here z is constant. Y dy, its integration is y square by 2 between the limit 0 to b. Put y equal to b, so b square by 2. Z dz. What is z dz integration? Z square by 2 between the limit 0 to c. So put z equal to c, so c square by 2. So b square c square by 2 into 2 we get 4. The lower limit automatically is 0. So this is for your S1. And then S2. S2 is nothing but the top. That means x equal to a. So n cap equal to I. Already f vector is given in the problem, which is x square minus yz into I plus j plus k. Here n cap I taken as I vector. I dot I only 1. What is I dot j, I dot k? They are 0. So that's why these two terms are get 0. So we have x square minus yz only. From this x equal to a. So a square minus yz into ds is dy dz. Once again, integrate this. Minus y is constant. When I am integrating with respect to z, then z square by 2 between the limit 0 to say, plus a square is constant, so integral dz is z between the limit 0 to say into dy. Either you can integrate with respect to y, z or zy. That's your choice. In both this case, you get same answer. So minus c square by 2. Once again, y dy integration is y square by 2 between the limit 0 to b, plus c a square is constant. Integral dy is y between the limit 0 to b. So put y equal to b, minus c square b square by 2 into 2 is 4, plus a square b c. So I'll write positive sign as first and then negative sign. This is for S2. The same way, see, S1 is b square c square by 4. Along S2 is a square bc minus b square c square by 4. When I add these two, then plus b square c square by 4 minus b square c square by 4 gets cancelled. So I get a square bc. Similarly, find out S3, S4. See, S3, S4. Then a square c square by 4, a b c square c minus a square c square by 4. When I add these two gets cancelled. So I get a b square c. First one, a square b c, and the second one, a b square c. Similarly, S5 is a square b square by 4, and S6 is minus a square b square by 4. Both this gets cancelled. We get a b c square. Say S1, S2, S3, S4, S5, S6. So I add all this. So finally your LHS is this minus sign plus sign cancel, minus sign plus sign cancel, minus sign plus sign cancel. So we get a square bc plus a b square c plus a b c square. So take a b c as common. Then you get a plus b plus c. I think your RHS is also same, a b c into a plus b plus c of the Gauss divergence theorem. Similarly, LHS is also same, a b c into a plus b plus c. Hence both LHS and RHS are equal. So Gauss divergence theorem is verified. In the same way, I can do the next problem under Stokes theorem. Verify Stokes theorem for f vector equal to xy I vector minus 2yz j vector minus xz k vector, where S is the open surface of the rectangular parallelepiped formed by the planes x equal to 0, y equal to 0, z equal to 0, x equal to 1, y equal to 2, z equal to 3, above the x, o, y plane. O is origin. So above the xy plane. See the difference between the previous problem and this problem. In previous problem also parallelepiped, this problem also parallelepiped. In previous problem the limits are given x equal to 0 to a, y equal to 0 to b, z equal to 0 to c. In this problem x limit given as 0 to 1, y equal to 0 to 2, z equal to 0 to c. That a, b, c are 1, 2, 3. The main difference is, in the previous problem the entire rectangular parallelepiped they are using. But this problem they clearly mentioned open surface of the rectangular parallelepiped. So open surface of the rectangular parallelepiped means we have 6 surfaces. Among this, the top one is open. That means we will consider only 5 surfaces. The top one is open, hence we will not consider this 6th surface. So S1, S2, S3, S4, S5 only. Okay, the problem is under Stokes theorem. What is Stokes theorem definition says? Interval say f vector dot dr vector is equal to double interval over s del cross f vector dot n cap into ds. See the Stokes theorem? Interval over c f vector dot dr vector equal to double interval over s del cross f vector dot n cap into ds. Okay, so for, and once again I will do right hand side first and then I will go to left hand side. The right hand side I need del cross f. So f vector is given in the problem xyi minus 2yzj minus xyzk. So del cross f they are asking. Del cross F means, you know, cross product is determinant. First I vector, j vector, k vector, and then del I component is dou by dou x, j component is dou by dou y, k component is dou by dou z, and then F vector. In F vector, what is I component? xy. What is j component? Minus 2yz. What is k component? Minus xz. Okay, this determinant expansion is I vector into dou by dou y of this. Here minus x is that there is no y term. Then dou by dou y of this value is 0. Minus dou by dou z of minus 2yz. So already I have minus. So this one is also minus. Minus into minus is plus. Dou by dou y z of this 2yz. 2y is constant. Dou by dou z of z is 1. So we have only 2y into I vector. Minus j vector into dou by dou x of this. Dou by dou x of this. So when I am differentiating with respect to x differentiation is 1. So we have minus z. And dou by dou z of this xy is 0. Hence we have minus z into j vector. And then plus k vector into omit the column and row. Dou by dou x of this. Here there is no x term. X dou by dou x of this is 0. So dou by dou y of x is constant. Y differentiation is 1. So hence x into k vector. This is your del cross F vector. So del cross F dot n cap. In S1 we have 5 surfaces. So the S1 is nothing but along x equal to 0. So x equal to 0 means n cap equal to minus I. When x equal to some quantity means n cap equal to plus I. So here I vector I taken. Already you know del cross F dot I vector is minus I. So here I dot I minus I is minus 1. So minus 2I comes into dy dz. I dot minus I is minus 1 into this 2y dy dz. Here y limit given in the problem as 0 to 2 and z limit given in the problem as 0 to 3. So minus 2 into y integration is y square by 2 between the limit 0 to 2. 2 gets cancelled, minus sign. I will put y equal to 2. So 2 square as 4. We have only dz. What is integral dz? Z between the limit 0 to 3. Put z equal to 3. So minus 4 into 3 is minus 12. And lower limit becomes 0. So this is for first surface. And the second surface the same way n cap equal to plus I. So here n del cross F already got it. Dot I only 1. J dot I and k dot I is 0. That's why I will not consider here. So do the same idea. You get it plus 12. Similarly third surface y equal to 0. That means n cap equal to minus j. So del cross F j component is minus z. So here I will consider that. You get 9 by 2 after simplifying all this. Similarly along y equal to 1 n cap equal to plus j. Previous one y equal to 0 n cap equal to minus j. Here y equal to 1 n cap equal to j. When y direction means ds is dx dz except y. When x direction means except x, that means dy dz. Here y direction, so dx dz. J dot j is 1, so minus z. Apply the limits integrating all this, you get minus 9 by 2. And similarly S5. Here n cap equal to plus k. So del cross F k component is minus xk vector dot k vector. It's z direction. That's why dx dy. K dot k is 1. So we have only x into dx dy. X integration is x square by 2 between the limit 0 to 1. Put x equal to 1. So minus 1 by 2 into dy. Integral dy is y between the limit 0 to 2. Apply the limit. 2 gets cancelled. You get minus 1. So we have only 5 surfaces. Because the 6th surface they mentioned as open the surface. Hence add all this. So S1 is minus 12 plus 12 plus 9 by 2 minus 9 by 2 and then minus 1. So all this gets cancelled, you get minus 1. So already your left hand sides are also minus 1, right hand side is also minus 1. Therefore your Stokes theorem is verified. Now we will move to Green's theorem. Verify Green's theorem for interval say x square into 1 plus y dx plus x cube plus y cube into dy, where C is the boundary of the region defined by the lines x equal to plus or minus 1, y equal to plus or minus 1. See in the graph, when you are drawing x equal to plus or minus 1, y equal to plus or minus 1 means it represents a square, because all the four sides will be sides length as 2. Therefore it represents a square. It's a Green's theorem. Green's theorem means integral over say p dx plus q dy, which is equal to double integral over r. Either you can write in m and n or pq, that's your choice. So here m and n they are using. So dou n by dou y minus dou m by dou y into dx dy. Now I consider the right hand side as first. What is the right hand side? Double integral over r dou n by dou y minus dou m by dou y into dx dy. So compare the problem with your equation. Here dx coefficient is x square into 1 plus y. In the Green's theorem formula, your dx coefficient is m. So compare m equal to x square into 1 plus y. Similarly, dy coefficient is n. In the problem, dy coefficient is x cube plus y cube. So n equal to y cube plus x cube or x cube plus y cube. So I want dou n by dou y. That means differentiate this n partially with respect to y. Y cube differentiation is 3y square and x cube differentiation is 0. Hence it's 0. And dou m by dou y I want. So dou m by dou y, which is nothing but here x square into 1 is x square plus x square y. So x square y plus x square and differentiate with respect to y. So which is x square. Hence your formula says 3x square minus x square is 2x square into dy dx or dx dy, that's your choice. Because the limits are minus 1 to 1, both are constant limits. If it is constant limits, then you can write dx dy or dy dx, then both will be same. So 3x square minus x square is 2x square. So 2 into x square integration is x cube by 3 between the limit minus 1 to 1. First substitute x equal to 1. So 1 by 3. Before the lower limit put minus. Already I have minus, so minus of minus plus. Put x equal to minus 1. So minus 1 whole cube by 3. So minus of minus is plus 1 by 3. 1 by 3 plus 1 by 3 is 2 by 3. 2 into 2 by 3 is 4 by 3. This 4 by 3 is constant. We have only integral dy. What is integral dy? Y. Between the limit minus 1 to 1. Put y equal to 1. And before the lower limit put minus 1. So minus of minus will be plus. 1 plus 1 as 2. 4 into 2 as 8 by 3. Call equation number 1. This is your right hand side. And come to the left hand side. The left hand side is integral over say m dx plus n dy. So m dx plus n dy, it forms a square. So square is AB, BC, CD, DA. This is a closed region. AB, BC, CD, DA. So this direction. In AB, that means along y equal to minus 1, that means the bottom one. Top is y equal to 1. Here x equal to minus 1. And this one x equal to 1. 4 directions are there. So when y equal to minus 1, take derivative on both sides. Here y derivative is dy. Minus 1 derivative is 0. And the x varies from left to right. So minus 1 to plus 1. So minus 1 to 1. M dx plus n dy. That means m dx plus n dy is given in the problem. This is m dx plus n dy. From this, dy is 0. That means this part is 0. And y equal to minus 1. When I substitute y equal to minus 1, here 1 minus 1. What is 1 minus 1? 0. So 0 into x square is 0. Integral 0 is 0. So the entire integration is 0. This is along AB. Next along BC. Along BC means this one. In this direction x equal to 1. Once again derivative on both sides. X derivative is dx. 1 derivative is 0. And y varies from bottom to top. That means minus 1 to 1. Hence once again put dx equal to 0 and x equal to 1. You get y cube plus 1 into dy. Substitute the limits and after integrating you get it 2. Similarly along CD and DA you can do. So along CD, that means the top one y equal to 1. So derivative on both sides dy equals 0. X is left to right, that means 1 to minus 1. Here x is 1 and this direction is minus 1. So substitute mdx plus ndy y equal to 1 and dy equals 0. So after all these things you get it minus 4 by 3. Similarly along DA you can do, that means bottom to top 1 to minus 1. When x equals minus 1 dx equals 0. So mdx plus ndy can substitute all this. Integrate and simplify, you get it 2. Hence finally add along AB, BC, CD, DA. So add all these things, you get it 8 by 3. This is equation 2. Already your equation 1, right hand side is also 8 by 3. And now after adding all these things, your left hand side is also 8 by 3. Hence equations 1 and 2 are equal. Therefore Green's theorem is verified. So these are the problems in vector integrations. Thank you students. If you have any doubts, you contact my mail ID delhimsc@gmail.com. That is delhimsc@gmail.com. Thank you students.